Hi guys. Okay, in this video I want to go over the basics of buffer overflows because the buffer overflow attack is one of the most commonly exploited vulnerabilities in a system, and it gets used everywhere. Even the earliest computer worms were working based on a buffer overflow, and it's still a common problem today. So it's pretty important to understand how this works. Since there's really a lot to it, there are a lot of machine level operations that you have to get used to looking at to be able to see where a buffer overflow might be possible and what it can do. I'm going to break this up into several shorter videos with just one example per video, just to introduce a little bit at a time to work up to how a buffer overflow can lead to arbitrary code execution. So I'm just going to introduce the basic concept in this one and show a simple example. So the buffer overflow is one of the most commonly exploited vulnerabilities, and it can corrupt program data to cause errors, and it can cause new executable code to be injected into an already running program. And what's happening is the computer allocates space in RAM for variables declared in the data section of a program, and some programming languages will not do boundary checking to ensure that the supplied data will fit into the allocated space. And this causes excess data to overwrite other data in RAM. So I've got a simple example here. In this program, all I have is two strings that I've declared and then a string copy and some print statements to show the contents of the strings. So you look in the data here, I've declared two strings that are each 12 bytes long. The first one I've just given it empty spaces, and then in the second one I've printed a message, that is all. So then in the code section, it's going to print a little message working, and then it's going to do a string copy. Then it's going to print the two strings to show the contents. So if I run this here, I called it ex1, and I just say hello. Okay, here we see it runs. It prints my working message, does the string copy, then it prints string 1, which has my command line argument hello. Then it prints string 2, which has my that is all message. And I can give it a longer string. Here, when it comes into the procedure main, it'll copy whatever is in the command line argument into string 1 without doing any boundary checking to make sure that it will fit in the 12 bytes that were allocated for it. And that's where the problem is. So I'll give this a slightly longer string. Let's say, I eat bacon. And that fits because the message here fits within the 12 bytes that were allocated for the string. But what happens if I give it way too much data so that it won't fit? So I'll say I eat way too much bacon every day. Now if I run it this way, here it prints my string 1, but you can see here my string 2 message has been corrupted, because it was supposed to say that is all, but when it started copying the data, it was too long to fit into what was allocated for string 1, so it overflows into the space that was allocated for string 2, and that's how this happens. So to take a look at what's going on, we write our program in C, and we compile it and generate a raw machine language program that can get executed. So to take a look at what that looks like, I'm going to do a hex dump. I'm going to say -c and my program name. And I'm going to pipe this into less so we can scroll through it. And this is just going to give us a raw hexadecimal data dump of this ex1 file. So here we can see it's got the file signature here that it's an ELF binary executable. And then it's got a bunch of prologue stuff that just tells the computer how to allocate what it needs. Now if I come down here we can see my messages. We've got this that is all string, and before the that is all part we see this string of empty spaces, and that's my data section here. I've told it to allocate 12 bytes of empty spaces for string 1, and then right after that it's going to allocate 12 bytes with this that is all message, and that's what we've got here. And the problem is, since there's no boundary checking on the string copy, if it starts to copy data into this space, but it's too long to fit, it just keeps copying until it's gotten to the end, and that overwrites what comes in the program after it. So to see that in action, we need to look at the machine language for what's happening. So I'm going to disassemble it using object dump. I'm going to say -D to tell it to disassemble the entire file. I'm going to give it my program name, ex1. And again, I'm going to pipe it into less so I can scroll through it. So here we have a lot of machine language for setting things up for the program to run. Okay, here's procedure main. It's got the name here, main, because as you expect in a C program, that's the main procedure that everything executes from. And here, it just has a call to printf to print this working message. Then it's got a call to string copy, and then 2 more print formatted calls that have actual formatted strings. So we can see here in the assembly language, for each instruction, it kind of moves around some data to set up for the call. Then it has this call to the put string, and that matches this first printf here. Then it'll move around some more data, have a call to this string copy. That's what's happening here. It's moving around data to set up some pointers for how to find this first command line argument and copy it into the RAM that was allocated for this string1 variable. And then it continues. It's got more moving around some more data, then a call to printf, and then moving around some more data, and then that last call to the print formatted here. But what we want to look at is where the data is. Here it is. So we've got our disassembly of section data, and this is where I've declared the variables here at the top. I've just declared 2 variables. They're 2 arrays, 12 bytes each. So we look down here, we've got string1, and then it's got my 12 bytes. This 20 is just the hexadecimal ASCII value for the space character. So it's got 12 of those, and then it's got the zeros for the null character that terminates the string. Then after that, it's got string2, and it's allocated this much space and filled it with that data, which corresponds to my that is all message up here. So what happens is, if the data getting copied into string1 is too long, it just keeps copying and filling up whatever is down here. So to see that in action, we need to run it in a debugger. So I'm going to say gdb, I'm going to say -q so it doesn't print all of its startup message. I'll say -args so I can give it a command line argument. Then the program that I want to debug, that's my ex1. And then I'll give it my string, I eat bacon. So now it's got my program loaded into the debugger. I can execute the program in here, but I want it to stop at the beginning of procedure main so I can see what's going on. So I'm going to set a breakpoint at main. And then I'm going to let it run until it gets there. Now it's run through the data segment, and it's allocated the space that it needs for all the data, and it's going to start at this print working here. So I'm just going to step past that because we don't really care about that. So now it's stopped here at this line 11. I can do a list and show the source code here. This is the line where it's about to do the string copy statement here. But if we look at it at the source code level this way, we can't really see what's going on. So instead, we need to look at the machine code that gets generated. So I'm going to disassemble main here. Here's the machine code that goes along with it. And like we saw in the object dump here, each one of these call statements represents a function call here in procedure main. And before each one, it kind of moves around some data to set up for the call. And the one that we're going to look at is this call to a string copy. And here's the data above it where it's moving data around to set up for this call to string copy. So we want to be able to look at what's in RAM that's going to be affected by the string copy call. So GNU debugger gives us this examine command. You say an X, and then you can specify a format. I want to look at 8 words of data, and then I'll give it an X to tell it I want to see it in hexadecimal format. because it's a hex number, I'm going to preface it with this 0x. Then I'm going to give it the address that I see here for my string1 variable. So when I put that in here, I can see for string1, it's allocated this space and it's filled it with this 202020. That's just the empty spaces here. Then below it for string2, it's allocated this much, and we can see that it's filled it with the ASCII values for my that is all message. So then, if I go back to my disassembly, we can see that it stopped here where it's just about to start the setup for the call to string copy. So we look at what the data looks like before the string copy call. Then we can step through that. Now it's stopped at this print formatted with string1. That's after the string copy call. So we can look at the data again, and we can see that it's changed. Where at first string1 had just the 20 for the empty spaces. Now it's got all of this data, which corresponds to the command line argument that got copied in there. And we can see it filled it up this much and then it stopped. And the data for string2 still matches what it had before. So from here, if I just continue, I see what I expect. I've got my command line argument data that I gave it, and then I've got my that is all string here. But if I go back and give it too much data, what did I say? I eat way too much bacon every day. Now again, I'll set my breakpoint on main. I'll run until it gets to the breakpoint. Now it's at my printf, so I'll step over that. Now I'm going to examine the RAM again. 8 words, hexadecimal format. Whoops. Give it my address for string1. So here's how it looks before the string copy call. We've got empty spaces at string1, and then we've got the original message at string2. So now I step into the next statement, which is that string copy. Now after doing the string copy, I look at it again. I can see my data has gone into this string1 area, but I can see that it's overflowed into the string2 space. Before, string2 here had this 74616854. Now it's got this 62206863, and it keeps going here. This is the rest of my long message that got copied into string1. It started copying here, and it just kept going until it got to the end, and that filled up the space that had been allocated for the next variable. So that's why when I continue from here, it shows that my variable had said that is all, but now it's just picked up the excess from this message. That's that buffer overflow where it filled up the buffer allocated for string1 and corrupted the data that was supposed to be string2. So I'm going to go ahead and quit here. Okay, that's all for this example. In the next video, I'll show a more complex example of how the corrupted data can affect the execution of the program. So that's all for this one. See you next time.